All right, so we've already had an introduction into this idea of energy, what energy is. Now, one of the kind of special cases we talk quite frequently about when we talk about energy is the transfer of energy from one object to another. Now, one of the ways that we can have that happen is through heat. Okay, so if we go back, we remember heat, we hopefully can define this as the transfer of kinetic energy from something that's hotter, right, has a higher average kinetic energy, to something that's colder, has a lower average kinetic energy. So that's a heat transfer there. Now we want to be able to measure this. We want to actually be able to quantify how much heat is transferred. Now we can't just simply take a heat measurement instrument and stick it into something and say how much heat is transferred. We need to actually have something that we can measure. Well, something that we can measure when we talk about heat being transferred is temperature. Okay, so let's go ahead and say we have two objects here. Okay, so we have something that's hot, something that's cold, right? We're just looking at relative terms. So we can say, well, initially they're separate from each other, so they would start at hot temperature, this would start at a cold temperature. Okay, that's something we can measure. We can measure temperature. Okay, well, after some time, okay, they are going to reach what we call thermal equilibrium. Okay, thermal equilibrium, just a special way of saying they end up at the same temperature. So now we see, okay, well, we have our two objects, one that was cold and one was hot. Now they end up at the same temperature. Okay, so now they're at the same temperature. Again, two values we can measure. So how are we going to look at the transfer of heat between these two things, right? We're going to have heat be transferred from the hot object to the cold object. Higher average kinetic energy, lower average kinetic energy. It's going to move that way. So we have our heat being transferred. We want to be able to quantify this. So we see it has to relate to something with our temperature change. So if we're going to look at heat, okay, so heat, Q, right? That's how we would say, we talk about heat, we shorthand with Q, is going to be equal to, now there's going to be two kind of conversion or relationship factors that convert between heat and temperature, because not everything gains and loses heat the same amount, okay? The first one is Q equals C times the change in temperature of that object. Okay, so C here is what we call our heat capacity. Okay, so that's one way we can measure how much heat is transferred from a measured value, right? Our temperature change. Another one is our heat equals mass times the specific heat times the change in temperature. So again, we have change in temperature in both of these, the measured value. Okay, here this is our specific heat, and again our mass here is shorthanded by M. Okay, so we look at both of these, they both give us the ability to measure heat from a temperature change. Now the difference here is this proportionality factor, specific heat, conversion factor, or heat capacity, excuse me. So let's go ahead and look at why we would talk about these two. Okay, heat capacity, if we look at kind of define what heat capacity, it is the energy, okay, so that would be joules, needed to change an object by 1 degree Celsius. Okay, so we take an object, we change its temperature by 1 degree Celsius, that's how much heat is required to make that happen. When we're talking about our specific heat here, what we're looking at here, we also have this mass component here. Okay, so our specific heat is the energy, so again, joules, required to change 1 gram of a substance by 1 degree Celsius. Okay, so again, we see there's a difference here. Our specific heat tells us, well, now this is now an intensive property because we're taking it per 1 gram. So our heat capacity is an extensive property. It depends on the amount that we have. So we talk about, well, when would we use these two? Well, we would use our heat capacity versus our specific heat. Let's talk about our specific heat. Specific heat is useful when it is a pure substance. Okay, so if it's a pure substance, that means if we have 1 gram here, 1 gram here, it's the same thing. That 1 gram is going to take the same amount of heat as this 1 gram to change temperature. Okay, so this is really useful if we have a pure substance. our heat capacity is really useful if we have a mixture or multiple components to it. Okay, so let's think about maybe we have a pure sample of copper. How much heat is needed? Like we have a copper pot. Maybe you're going to go do some cooking. How much heat is needed to change that copper pot by a certain temperature? Well, now we go ahead and we pour water into it and salt and maybe some other things. Well, now we can't just talk about our specific heat capacity. Now it has a bunch of different components. So now we would talk about the heat capacity of that whole system. The copper, the water in it, salt in it, everything. And so that's when it's helpful to talk about heat capacity. We have all these different multiple components. Whereas we can talk about our specific heat very easily if it is a pure substance, right? We can go ahead and we can look this up in a table and identify, well, we have copper, iron, water, etc., what the specific heat of that is, okay? A final thing I want to mention is the typical units that we use. Typically with our specific heat is going to have units of joules per gram degree Celsius. We can also write this as joules inverse grams inverse degrees Celsius. Now when we talk about our heat capacity, this is a per gram value, right? Our heat capacity is going to be in units of joules per degree Celsius, okay? Or we can write joules inverse degrees Celsius. Okay, so this is real important to identify or know when we would use these different units, okay? Will they correspond to specific values? So hopefully this gives us a good idea of when we would talk about our heat capacity versus when we would talk about our specific heat capacity, and how that relates to this idea of the measured value. Change in temperature is our measured value. Well, we have these two things available to us to look at proportionality factors for how much heat is actually absorbed or lost when they undergo that temperature change.